Hello KCET 2025 aspirants. Today I am going to discuss a very important chapter from your PU2 syllabus, that is wave optics. And in wave optics 3 to 4 question comes almost every year, and there is a question which comes almost every year, one single topic concept related question. So we are going to discuss that type of question as well. So without much delay, let us start with today's lesson. First we will look into the most important concept from this chapter. So most important concept are Huygens principle, obviously the wave theory of Huygens theory or wave theory of light. Then we have coherent and incoherent light. We have Young's double slit experiment or YDSE. Then we have diffraction, then we have polarization and Malus law. So these are very small concepts, not too much there because derivations are not there. Also the part from Young's double slit experiment are deleted, the fringe width, etc. There are not too many things are there in this chapter, but still there are enough for 3 to 4 questions, and you can easily answer those questions if you follow this lecture. Now let's start with first concept, which is Huygens principle. So what is Huygens principle? So Huygens principle, before knowing Huygens principle, you need to know about wave front. Okay, what is a wave front? Wave front is the defines as the surface of constant phase, or we can say that locus of points having same phase, or locus of same phase. Locus means what? If you there are few points, okay, if you join them, then this is called locus. Locus means a path, and path means all the points which are at the same phase. Then if you join them, that is called locus of the same phase, and that is called wave front. So this is wave front, where all the points on this line basically are at the same phase. It can be a surface, it can be a line, it can be not volume, it can be either surface or a line. In 2 dimension, in 3 dimension, it will be a surface. Okay, now the speed with which the wavefront moves outwards from the source is called speed of wave. So the speed of the wavefront is same as the speed of it. So if I say that a light is moving in vacuum, then that speed of the wavefront in vacuum will also be 3 into 10 to the power of 8 meter per second. Okay, so wavefront and light, they all travel with the same speed. Now, according to Huygens principle, each point of the wavefront is the source of a secondary disturbance called wavelets, and the wavelets emanating from these points spread out in all directions with the speed of wave. So suppose this is a wavefront, all points on this wavefront will be a source of secondary waves called wavelets. Wavelets means child wave. Okay, and these child waves all are traveling with the same speed as the wave. Okay, so they are all having, and they are propagating on all possible direction. What is the meaning of that? For example, if I consider a point source is basically emitting light in all possible direction. Similar to that, a wavefront is also any point in the wavefront basically behaving like a point source. That was Huygens principle, right? Now the wave emanating from the, emanating means emitting, okay, coming out, emanating means coming out from the wavefront are usually referred to as secondary wavelets, and if we draw a common tangent to all these spheres, we obtain the new position of the wavefront at a later time. What is the meaning of that? So if you see that this is the primary wavefront, this is called the primary wavefront. At starting at the beginning, this is the primary wavefront. All the lights are traveling over here. Okay, after some time all the rays actually reached over here. So this is the secondary wavefront. These are the secondary wavefront. What are these? These blue lines are secondary wavefronts. Now if you draw a common tangent to all of them, if you draw a common tangent to all the secondary wavefronts, you will get the next wavefront. So this is the primary wavefront, this is the second wavefront. Okay, and so this will also be a primary wavefront, but after some time. And if you draw a common tangent in the behind space, you will get the previous wavefront from where the light started. So if you know a wavefront at any point of time, you can consider them to be the source of light, possibly traveling in all possible direction. Then you take the common tangent to all such lines, and then you get the wavefront after some time. Okay, so what will be the shape of the wavefront if I say after, say, time t? So after time t, you have to consider all the secondary waves, and then you have to draw a common tangent. Then you will get the wavefront after time t. Okay, this is called new position of the wavefront. Now let's move on to a problem. When light propagates through a given homogeneous medium, the velocities of primary wavefronts are lesser than those of secondary wavefront. Primary wavefronts are greater than that of or equal to those of the secondary wavelets. Primary wavefront and wavelets are equal. Primary wavefronts are larger than that of the secondary wavelets. So primary wavefront and wavelets all are equal, right? So primary and secondary both have same speed. That is the Huygens principle. And if you want to be at the same speed with all other students who all are preparing for KCET 2025 exam, then definitely you should consider buying this 1499 pack for your KCET preparation Abhyas KCET test series. Okay, now current price is 1498. 1 rupee was there for your PU2 test series. Now PU2 obviously PU2 exams are almost at the midway. Maybe you are not interested in buying the PU2 test series, so 1498 if you pay now, you will get access to 31 paid test series. It will start from 17th of March. Okay, as soon as your PU exams are over, from there on, from 17th of March, the test series will start, and it will continue for almost every day, along with live doubt clearing sessions, along with detailed video solutions of all the papers that you are going to solve. If you have any difficulty, PDF solutions will be there, video solutions will be there, and also chapter wise one shot revision videos will be there. Chapter wise insight for last 5-year KCET papers will also be there. So everything you will get at one place. You don't need to browse through a lot of content. Only one thing that you have to do, you have to go to the link below, register yourself today, and if you don't want to buy right now, you can get the 4 free test series, 4 free test papers available right now with solutions, etc. You can check that out, and if you like it, you can purchase it after your PU exams are over, right? Now let's continue with next part, coherent and incoherent sources. What is coherent sources? Coherent sources are the phase difference between the displacement produced by each of the waves does not change with time. So suppose you are standing in a queue. You are standing in a queue, and some of your friend is also standing in a queue during COVID time. Remember the COVID time, they all said that you have to maintain one arm's length distance between you and your whoever is standing in front of you, right? So that arm's length rule is still being followed. Suppose in a queue you are standing for a certificate for KCET, you went to your college for some applications, and you are standing in a queue for, suppose, collecting your admit card. Okay, now you are standing in a queue. Now whenever your friend is moving forward, you are also moving forward by the same distance. If this distance continues throughout the motion, then we will say that basically you and your friend are coherent sources. Okay, the line is a coherent source. Okay, but if your friend say moves 3 paces, you move 4 paces. Okay, so then it is not coherent. Obviously that is not coherent, but in case somehow if we can lock the phases of 2 different sources, then that is called coherent sources. Now 2 individual separate sources cannot be coherent. To make them coherent, it has to come from a single source, and we have to divide it like Young's did. We will see that in a while. So coherent source means phase is locked, so their phase cannot change with time. or with space. If you consider a particular space, that space will always have a fixed phase difference. If you consider a particular time, at that point of time the phase difference will remain same. Okay, so that is what is called phase locked condition or coherent sources. Now incoherent sources are easy. Those who do not follow any rules, they are called incoherent sources. So there is no phase relation between the waves. So the example I gave you, your friend moves 3 paces, you move 2 paces, or your friend moved 2 paces, you are moved 3 paces. So if the gap between you and your friend keep on changing, then there is no phase condition. So we will say that is a incoherent source. Okay, the light waves coming out from two independent sources of light will not have any fixed phase relationship and would be incoherent. So if you take one torch, if you take another torch, if you light them up, then they are considered to be incoherent sources. Okay, there is no phase relationship between two different torches. But if you can somehow split the light from a single torch into two different parts, they can be considered as coherent sources. Next is superposition principle. Superposition principle we have learned in physics in many cases. Okay, in case of vectors, in case of electric charges, electric forces, again in case of waves is also sound also we have learned about superposition principle. Here we are learning about light waves. So superposition principle is at a particular point in the medium, the resultant displacement produced by a number of waves is the vector sum of the displacement produced by each of the waves. So what is the meaning of that? Suppose at some point we are observing some light intensity, okay, and here we are receiving light from various sources. Okay, so what will be the resultant intensity at this point? So you have to take individual displacement. Displacement means so basically if you consider this is the wave, okay, at any point of time, light say at this point, so this is the displacement. Okay, another wave which is coming, it came like this. So this is the displacement for the second wave, and the third wave which is coming like this. They will all have different amplitude, so this will be the displacement for the third wave. At the same point, this is the displacement for all the individual waves. Okay, if you add them, so some of them will be positive, some of them will be negative. That is why it is called vector sum. Okay, if you add all of these, you will get the resultant displacement. It can be 0, it can be a maximum, it can be minimum. Okay, based on all the waves that they are interfering with. Okay, so this is called superposition principle. So suppose we have two waves, one is y1 is equal to a1 sin omega t, that is common displacement. Basically in the wave term we are ignoring the kx minus kx term which is taking it forward. We are only considering the displacement of the wave. Okay, only the amplitude, basic amplitude of the wave a1 sin omega t. A1 is the amplitude, maximum amplitude. A1 sin omega t will give you the temporal amplitude. At particular time, whatever is the amplitude, that can be calculated using a1 sin omega t formula. The second wave which is coming, say that this one is a1 sin omega t plus phi. Phi is the phase difference between these two waves. Okay, so from there we can find the resultant amplitude of the wave is a1 square plus a2 square plus 2a1 a2 cos phi. So based on whatever is the value of phi, resultant amplitude will vary. Okay, resultant intensity is basically proportional to this r square, and from there we can even say that I is basically proportional to a1 square plus a2 square plus 2a1 a2 cos phi. Now based on the whatever is the value, if cos phi is 0, then it is just simply a1 square plus a2 square. If cos phi is minus 1, then it will be a1 minus a2 whole square. If cos phi is plus 1, then it will be a1 plus a2 whole square. So based on whatever is the value of cos phi, the intensity will change, right? Now interference of light, a phenomena that occurs when two or more light waves interact with each other, causing the combined amplitude of the waves to increase or decrease. So for example, I gave you the last example where two waves are interfering, right? So intensity of the light, what was that? Intensity of the light was a1 square plus a2 square plus 2a1 a2 cos phi. So this is the interference. Basically this is interference. Now if based on the position and based on the phase difference, if cos phi is 0, then obviously I is proportional to a1 square plus a2 square. Okay, now if cos phi is plus 1, then you will get I is, if cos phi is 0, some whatever value cos phi is 0, that is 90 degree, cos phi equals to 1, then you will get intensity proportional to a1 plus a2 whole square, and if cos phi is equal to minus 1, you get I equals to a1 minus a2. Now a1 a2 can be same, may be same, may not be same. If a1 a2 is same, then this is the maximum intensity for a square. If a1 a2 is same, then minimum intensity will be 0. Okay, so this is minimum intensity, this is maximum intensity. Okay, so when two waves interfere based on the phase difference, then we get maximum intensity and minimum intensity. That is called interference. Okay, so interference is nothing but when two sources of light traveling together, two or more, but for our convenience we will consider, we will restrict it to two only. Two sources here we can see that they are traveling in the same direction, and after some time they are meeting at this point. As you can see that this light is traveling far smaller distance compared to this light. Okay, so there will be some phase difference between them. Okay, path difference, and basically path difference is there, means phase difference will also be there, and based on that we can say that the light are interfering with each other, and if they have the same intensity, then at intensity maximum we will get maximum intensity 4a square. If they are interfering destructively, when they are cancelling each other, is called destructive interference. That is this condition. Okay, then intensity will be 0. Now this is a condition where I told you these two are not independent sources. These two are not independent sources. There is a mother source somewhere here, which is S. Okay, and we have created them using some mechanism. Okay, Huygens created them using some slit. Slit means if you take a paper, if you cut it, then whatever gap that you see through the paper, that is called a slit. Okay, so slit, and this ray of light is basically one source is getting splitted from two points. Now at this, up to this point, both of them are at same phase. Now after this point they are getting split, so that is why it is behaving as coherent sources. Okay, so YDAC, that is Huygens double slit experiment. In Huygens double slit experiment, he observed the experiment and he determined that what is the condition for maximum, what is the condition for minimum. So in terms of path difference, interference maximum is given by, so this is called path difference. It is also written as delta x, this is delta phi. Okay, in terms of path difference, if the path difference I showed you in the last case as well. Okay, if you see that this is called, this distance is called path difference. So this distance, if it is an even multiple of if it is multiple of n lambda, then we say this is a constructive interference. Okay, if it is n lambda, then it is called constructive interference. If in terms of phase difference, that is cos phi, if it is 2n pi, okay, very important, 2n pi, where n value of n is fixed, 0, 1, 2, 3. Now what is the meaning of that phase difference? Let me explain you in terms of phase difference. So phi 2n pi, so 2n pi means what was the term that is involved? It was cos phi, so cos 2n pi. Okay, so what is the meaning of that? It means that it is always equals to 1. Okay, if you put 0, cos 0 is 1. If you put 1, cos 2 pi is also 1. Cos if you put 2, that is cos 4 pi, that is also 1. So it is always coming as 2 pi, 4 pi, 6 pi, like that. Okay, so that is why cos 2n pi value is always 1, and this is the condition for path difference. In terms of path difference, xd by d equals to n lambda. Now from here you can calculate the position of the the interference maximum. This is the position formula. Position for interference maximum is n lambda d by d. Okay, n lambda d by d. Phase difference is pretty simple. Now similarly, destructive interference, when they are cancelling each other, so when it is happening, when x d by d is equal to n plus half into lambda. Okay, again same value, same condition, and phase difference, this is also delta x, this is delta phi. Okay, so phase difference, it is 2n pi, 2n plus 1 into pi. So if you put the value of n equals to 0, you get the value of pi, right? So pi means cos phi is minus 1. So based on whatever cos phi is minus 1, you get minimum interference, right? We have seen that. So this is the basic condition. Also, in case if you want to explore this a little bit further, what is the this is delta max, x max, this is x mean, equals to n plus half lambda d by d. Okay, so this is the condition for minimum. Now let's see one problem. In Young's double slit experiment, two wavelengths lambda 1 is equal to 780 nanometer and lambda 2 equals to 520 nanometer are used to obtain interference fringes. If the nth bright band due to lambda 1 coincides with n plus 1th bright band due to lambda 2, then the value of n is. So what is the position for nth bright band? We know that is n lambda d by d. Okay, this is xn. Now this is happening for wavelength lambda 1, and xn plus 1. For lambda 2, it is n plus 1 lambda 2 d by d. Right, so this is the condition. Now from here what we can say that they are basically overlapping with each other. So overlapping with each other means n lambda 1 d by d, same, of everything else should be same, equals to n plus 1 lambda 2 d by d. So d cancels, d cancels. So what we get, n into lambda is what? Lambda 1 is 780 nanometer. Now nanometer, because it's an equation, so we don't need to write 10 to the power of minus 9, they will cancel anyway, and lambda 2 is 520. So n plus 1 into 520. So zeros cancels, it will be 39 26 by 2. Now you can cancel with 13, so 3 13s are 39, 2 13s are 26. So you get 3n equals to 2 into n plus 1. Just be patient. Okay, this kind of questions, if you see this kind of questions, be patient, follow step by step method, and you will eventually get the solution. So what is the answer? 3n minus 2n equals to 2, or n equals to 2. Okay, so the value of n is equals to 2. So option C is correct. Let's move on. Diffraction. Bending of light around a sharp edge is called diffraction. So if you see that, as you can see, the light is traveling through a very small hole which is very sharp, and the light after passing through this hole, it is giving rise it is showing you that normally what we expect according to ray optics, the light should travel in this direction only. Okay, and you should get only one single dot. So what you are expecting is to get a single dot at this position, nothing else should be there, right? That is what we are expecting. From the childhood also we have drawn the ray diagrams like that. Now when you are doing the experiment, instead of getting one single dot, you are getting some small dots on the sides as well. So why it is happening? Because light, according to Huygens principle, they are not going in a straight line. From here secondary waves can travel in all possible direction, and that is why you are seeing the diffraction pattern. So Huygens principle can easily explain the diffraction pattern. That is why it is very, very important to understand. And this bending of light on the sharp edge is called diffraction. So light bends from this edge to this side, and this side like this. So this bending of light on the sharp edge is called diffraction of light. So interference and diffraction, light energy is redistributed in both interference and diffraction. Light energy is redistributed. What is the meaning of redistributed? So if you see interference pattern, you will get a bright area and a dark area consecutively. All the distances would be of same distance. Okay, the gap should be same. That is called fringe width. Anyway, fringe width formula exactly is not there in the syllabus. But you should remember that interference patterns are equally distributed and they are equally bright, equally dark. Okay, so what is happening if you don't put that slit there? Everything will be completely bright, but overall intensity is not same. So what is happening is the intensity of light is basically redistributed. Redistributed means what? In some places they are adding up, in some places they are cancelling each other. So the energy, total energy of the light still remains same. Here as well, the light which supposed to brighten the entire only this dot, it is basically some part of this light is getting transferred into the other half. Okay, other side. Let's see one real diffraction pattern. So as you can see, it is thrown through a very small hole, and as you can see, there is a bright spot at the center as expected, and we are also seeing some very decreasing, ever decreasing secondary maximum. These are called secondary maximums, and their width are decreasing, their intensities are also decreasing. This is the central maxima, which is highest width, highest brightness, and as you are moving away from it, the intensity and the distances are decreasing. Okay, so this is very interesting picture of diffraction. You can try if you have laser light, and if you have two blades, you can put them together and you can observe diffraction pattern. It is very common experiment. Now, polarization and Malus law, this is the last concept but not the least, because as I said, there is a concept from where almost every year a question comes, which is basically polarization as well as Malus law, okay, combined. So in if an unpolarized light, what is unpolarized light? In EM wave chapter, we have learned that light is basically produced by vibrating electric field and magnetic field. Okay, light comes out of the page or into the page based on the directions of electric and magnetic field. Now if you so this is the condition, light, suppose this is the direction of light, this is the direction of light, this is let me show the conventional way only. Suppose this is electric field, this is magnetic field, this is the propagation of light. Okay, this is the direction of propagation of light. Now what is happening here is this configuration is still possible as long as this E and B, if you rotate this E and B, suppose this is E and B, right? Now if you rotate it slightly, then also the common perpendicular will still be in this direction. So all possible, so this is electric field and magnetic field, this is the direction of light. If you rotate them, okay, all possible direction, the direction of light will not change. So any configuration of electric and magnetic field along this plane, as long as they are perpendicular, you will get a electromagnetic wave in the same direction. So basically, if we only consider the electric field, magnetic field is weak and we do not want to jumble up the diagram. So if we consider only electric field, all possible electric field configuration can give you the same direction of electric field. Light wave. Okay, so all possible vibration of electric field will give you the same direction of light wave propagating, considering magnetic field is also present, which is perpendicular to the electric field, right? So this is called unpolarized light. This is an example of unpolarized light. Okay, all possible frequencies, all possible vibrations are present in this. Now when an unpolarized light, this kind of light wave is incident on a special crystal called Polaroid. Okay, there are few crystals which can do this. Okay, tourmaline is one of the examples. Crystal, they are special obviously and expensive. called polaroid, then the light wave will get linearly polarized. What is the meaning of linearly polarized? So if you keep that crystal, the crystal design is generally shown like this, okay, this kind of structure. This is the structure of crystal. So once the light passes through it, all of this vibration will be aligned only in one direction, okay, only in one direction, okay, no other vibrations will be present in this. This is called polarized. This is polarized. This is unpolarized. Okay, so polarized light, once it is passes through that crystal, all of the electric field vibrations, they align only in a particular direction. Either it can be in this direction or it can be other direction. Okay, now based on the different requirement, there are different types of polarization: circular polarization, elliptical polarization, but those are not part of your syllabus, not part of your curriculum. If you study optics in higher class, if you study physics in higher class, then you will learn about them as well. Now, light waves will get linearly polarized with the electric vector oscillating along the path axis. So this is the path axis. This is called the path axis. Okay, and the oscillations will always vibrate in the direction of the path axis. Okay, oscillating along the path axis of the polaroids. This is called polarization. Okay, the intensity of the polarized light is half of the unpolarized light. Very important line. Okay, half of the unpolarized light. What is the meaning of that? Suppose the intensity of the incident light is I, then after polarization this intensity will be I by 2. Very important, tumba important. You have to remember this clearly. Polarization of light proves that light is a transverse in nature. Okay, because the vibrations are happening in all possible direction, and after polarization it is only aligned in a particular direction. That means light was a transverse wave. Okay, if it was a what should I say, if it is a longitudinal wave, then all vibrations should have present. No one could have dampened it like this, but because it is a transverse wave, some of the part is getting absorbed. Okay, now there is very important, which is Malus law, which says that when light of intensity, say polarized light, suppose I have a Polaroid. Okay, after this, suppose a light of intensity I naught is coming out of this Polaroid after polarization. I have a second Polaroid which is slightly at some different angle. So this is the path axis of the first Polaroid, this is the path axis of the second Polaroid. So with respect to the path axis, the angle, say theta. Okay, let me clear this. So suppose we have let us consider a polarized light itself, a polarized light. This is the symbol for polarized light. So polarized light of intensity I naught, it is passing through another Polaroid. The angle of this Polaroid with the electric vector is, say, theta. Now what will happen to the light which is coming out of this? Will it completely be zero? Or it should have some component still left. So it will not be zero. Some component of this light will still align itself. After the polarization, obviously it will align along the it will align along the direction of the second Polaroid like this. Okay, so this is the emergent light, but its intensity will reduce. How much it will reduce? It will be new intensity will be I naught cos square theta. So if this is theta, if this is I naught, then it will be I naught cos square theta. Now remember that in Malus law, this I naught is the intensity of the polarized light, not the unpolarized light. Very careful. It is only for Polaroid, only single Polaroid. Polarized light is coming to the Polaroid, then this intensity of the light after polarization is given by I equals to I naught cos square theta. So we will see a problem. Every last 5 years there was one question based on Malus law. Okay, so there was one question which based on Malus law. Let's see this question, I think from last year 2024, and this is the most difficult question. out of all the questions. 3 Polaroid sheets are coaxially placed as indicated in the diagram. Pass axis of the Polaroids 2 and 3 makes 30 degrees and 90 degrees with the pass axis of Polaroids 2 and 3 makes 30 degree with 90 degree with the pass axis of Polaroid sheet 1. If I0 is the intensity of the incident unpolarized light entering the sheet 1, the intensity of the emergent light through sheet 3. So first of all, let us understand this question. So light of intensity I0 is entering this. The angle between this and this is 30 degree. This starting and ending is 90 degree. So what is the angle between these two? Angle between these two is 60 degrees. 90 minus 30, 60 degrees. It is important, not the starting and ending. The consecutive to Polaroid, angle between consecutive to Polaroid is important. So if this is 30 degree, this is 90 degree, the angle between these two are obviously 90 minus 30, which is 60 degrees. Now the light which is entering through this, okay, after polarization, it should be I0 by 2. So intensity of the so the student who solved it, the student used this method. So I will also recommend you do it in the first stage. You should do it in the exam question paper itself. So I0 entering, so it will be I0 by 2 after passing through the first Polaroid. Okay, after passing through the first Polaroid. Now what is the intensity of the light which is coming out of the second Polaroid? For second Polaroid we will use the Malus law, that is I equals to I0 by 2. Why I0 by 2? Because the light which is entering this Polaroid is I0 by 2. So I0 by 2 cos square, what is the value? 30 degree. Cos square 30 degree. What is the cos 30? Cos 30 is 1 by root 3 by 2. Sorry, cos 30 is root 3 by 2. So cos square 30 degree is 3 by 4. Okay, 3 by 4. So 3 I0 by 8. Okay, 3 I0 by 8. So this is the light that is emerging. So the student has already done that. So I0 by 2, 3 by 4. Why 3 by 4? Because it is cos square 30 degree. Cos square 30 degree means root 3 by 2 whole square. So be careful, root 3 square is 3 divided by 2, that square is 4. So it will be 3 I0 by 8. Okay. So 3 I0 by 8. Now next angle is 60 degree. What will be the output? So now the input is 3 I0 by 8. So input for this is 3 I0 by 8 and the angle is 60 degree. So third Polaroid it will be I0, 3 I0 by 8 into cos square 60 degree. Cos 60 means what? Cos 60 means cos 60 is half. So cos square 60 means 1 by 4. So 3 I0 by 8 into 1 by 4. So it will be 3 I0 by 32. So this is the final intensity, 3 I0 by 32. So if you follow the steps, follow the process, you can answer it. Okay, so every year, almost last 5 years, similar questions comes. So you have to practice those 4-5 questions and get ready for your KCET 2025 preparation. Also, if you want, join our Abhyas KCET test series, where we will be solving a lot more questions like this and all subjects included. Okay, so I will be seeing you in a new lecture very soon. Till then, bye.